Time to roll on to Unit 2. So take a look at this this packet, a little thicker than the last one. Fraction operations. This usually is a struggle. So stay with me. Watch these videos. I shoot them every morning, so hopefully they'll help you out. So hope you enjoyed Chapter 1. Time to move on to Unit 2. Okay, Unit 2. Okay, so make sure it's saying Student Handout 1. And I call this Chapter 2 Unit Lesson 1. That's kind of how I label it. But let's talk a little bit about vocabulary here. A number is composed of other numbers called factors. Factors are numbers in a multiplication problem. That is the product. So 2 and 3 are the factors of 6 When a set of numbers has the same factor, it is called a common factor. The greatest, G-R-E-A-T-E, greatest common, and I'm going to come up here, factor, or GCF, is the largest factor that a set of numbers has in common. So we're going to now, instead of saying greatest common factor, we're just going to use the abbreviation of GCF. All right, so there's several methods to do this. All right, this is probably the easiest method right here. All right, factoring down using a factor tree. I don't really like this Venn diagram, and really, I'll be honest, I don't like this ladder method. So let's just stick to one method and get good at it. Let's use a factor tree to find the factors of 15. So I know through my facts that 3 times 5 is 15. And what you're going to notice is that I'm going to circle these. These are what we call prime numbers. A prime number has two factors. One in itself. 1 times 3 is the only way to get that. 1 times 5 is the only way to get 5, right? 60 is a little bit different. I like to start when it ends in a 0 with 10, because 10 times any number, right, we just add that 0. So 10 times 6 is 60. Now, neither one of these are prime. They are what we call composite. Composite has more than two factors. So let's factor it down to prime numbers. Those are both prime. And 2 times 3 is 6. Those are both prime. Okay? So if we look at it from a Venn diagram, okay, well, see here, 15 and 30, they both have the common factors of 3 and 5. So on the overlap, we would write that. Outside the overlap, I would write a 2 and a 2. There's nothing in this 15 piece because these were common factors of 60. Or another way to write it is, okay, just find the common factors. If they appear in both lists, okay, write it down. 3 and a 3. Cross them off 3 times. 5 and a 5. All right. What's the greatest common factor of these two numbers? 3 times 5 is 15. Or if you look at it, 3 times 5 is 15. So the GCF, the greatest number, the biggest number that goes into both of those is 15. Okay, is 15. All right. So I'm actually going to skip this ladder method. I don't like it. I think it will confuse you. So let's come down to number 1. Okay, so number 1 they want to know the GCF of 24 and 6. So what I like to do is write them out like that. And then I'm going to come over and factor it. 6 times 4, 2 times 3, those are prime, and 2 times 2. And then I'm going to come over to 6. 6 is a composite number. It's 2 and 3. So those are the factors of 6. These are the prime factors of 24. Now, what numbers appear in both lists? Okay, a couple different ways to do it, but I have a 2 and a 3 here. Excuse me, a 2 and a 2. I'll cross those off. And here's a 3 and there's a 3. So 2 times 3 is 6. The GCF is 6. 6 times 4, 1 times 6. Bang, Bob's your uncle. Okay. Now, there is a way to do this with your calculator, and I'm going to show you that right now. So if you want to pause the video and grab your calculator, go ahead. And let's just check it, okay? Because we're going to actually do it for the next one because I want to make sure that we're utilizing our deal here, okay? So go ahead and turn it on, clear it. All right, I've cleared mine. And what we're going to do is come to the math button, okay? And when we come to the math button, we're going to look for this GCD. That's actually on your calculator, the GCF. So I'm going to come down arrow 1 and enter. And there it is. So I want to know what the greatest common factor of 24 and 6 is. And let's see if it's 6. So I enter 24. And what I have to do, guys, is I have to separate these two numbers with a comma. How do I get a comma? How do I get that function of that button right there? Well, if I hit that button, you'd see a decimal come up. I don't want the decimal, so I'm going to go ahead and delete that back. What I want that is, so I'm going to hit the second function of that button and I get a comma. And then I enter the number 6. And then if you want to, you can close the parenthesis. And then just hit enter and you get 6. So that's a way you can find the greatest common factor with your calculator, okay? All righty. So let's move on. Let's factor 18, 24, and 60 down, okay? So 6 times 3, 3 is prime, I circle it. 2 times 3, okay? 24, 6 times 4, 2 times 3, and 2 times 2. These are prime. They are going to get circled. Remember, prime means that there's only two numbers that make them up, one in itself. 60, again, we had that earlier, so we're going to start with a 10 and a 6. 2 times 5, they're both prime. And 2 times 3, they are both prime. Now, when you have a triple stack, you have to find the number that appears in all three lists. So I have a 2, I have a 2, and I have a 2. So I write it down. All right, I have a 3. Do I have a 3 here? Yep. Do I have a 3 here? Yes. And I write it down. Now, let's check this one. Here's a 3, but there's only 2's left here, and there's only 2 and a 5 left here. So there's nothing else that is common in all three lists. And the answer is 6. So the GCF of 18, 24, and 60 is 6. The greatest number that goes into all three is 6. 6. Calculator will do it. Okay. And I can show you how right now. Turn it on. Hit the math button. Come down to GCD. Hit enter. Now, when it's a triple, we're going to find the first two numbers. So the GCF of 18, second decimal, and 24 is 6, right? It's 6. So now I'm going to find the GCF of 6 and 60. That's how you have to do it with three numbers. So I'm going to do the same thing. Come down to GCD, and I'm going to hit 6, and I'm going to hit second and 60. And you'll find out that it is 6, which is what we found. So that's how you have to do it with a triple stack, okay? Greatest common factor, good stuff. Let's flip it over and get to the other side. Now, on the other side, they're going to talk about multiples. A multiple of a number is just counting by that number. When you multiply it by 1, by 2, by 3, and you're going to see how this sets up. A multiple of a number is the product. It's the product of multiplying that number by another number. The first 5 multiples of 7. Well, 7 times 1 is 7. 7 times 2 is 14. Now you're seeing why we were hammering our multiplication facts. 21, 28, and 35. Those are the first 5 multiples, times 2, times 3, times 4, times 5. The least common multiple is the smallest common multiple of a set of numbers. So it's the one that appears in both lists after you count by those numbers. Well, what do you mean? Well, let's get into it and let's see what we can do here. When I count by 4, 4 times 1, and I like to draw a line, times 2 is 8, times 3 is 12, times 4 is 16, times 5 is 20, 24, 28, 32. How far do you take those out? As far as you need to, right? I just filled up the line. 9 times 2 is 18. All right, and I'm looking for a common number that appears in both lists, okay? So let's continue. So I'm already up to here, so let's go times 3 is 27. Nothing there. Times 4 is 36. 9 times 4 is 36. So if I carried this one more, I would see that 36 is the smallest number that appears in both lists, and we would write 36 down. Okay, so the smallest number, the least common multiple that appears in both lists is 36. Let's try that again. And let's do it with our 3. 3, 6 times 3 times 4 times 5 times 6 times 7 times 8. I filled up my line. All I'm doing is counting by that number or multiplying it. 7 times 1, no 7. Times 2 is 14. Uh-oh, I do have a 14, but I made a mistake, didn't I? 3 times 4 is 12, and I wrote 14 down. That's a problem. That happens. Times 3 is 21, and there it is. So what number appears in both lists? What's the smallest? 21. Now you ask, can your calculator do that? Sure, it can. Okay, so let's go ahead and check it out. So let's see if we are correct with the LCM of 4 and 9. And again, we're going to go ahead back and revisit, all right, that same button, that math button. But instead of coming down to GCD, I'm going to use the LCM. Hit enter. And I'm going to do the exact same function. I'm going to enter the number 4, and I'm going to hit second comma. I'm going to enter the number 9, and bang, there it is. And you'll see that the LCM of those two numbers is 36. Oops, you can't see that, can you? How about that? All right, let's try one more. LCM of 3 and 7. I just hit the math button, I hit enter. Here's 3, second comma, 7, hit enter, 21. You notice I don't have to close that parenthesis, and there it is. Okay. All righty, let's keep rolling. All right. Armani and Ethan planned an end of season soccer party. They purchased 45 hot dogs and 30 individual bags of chips. If each person will receive the same amount of food, what is the greatest? Greatest tells me GCF number of people that they can feed without having any leftovers. And what will each person receive? Okay, so if there's 45 and 30 GCF, we're going to have to use our factor tree. We'll check it. We'll do this one old school by hand, and we'll do this one with the calculator. How's that sound? All right, so 9 times 5 and 3 times 3. If you know your math facts, you'll be able to do it faster without the calculator. 10 times 3 and 2 times 5. Okay, and there they are. So what numbers appear in both lists? Here's a 3, here's a 3. Write it down. Here's a 5, here's a 5. Write it down. A 3 here, but a 2 there. We're done. 3 times 5 is 15. 15 what? 15 people can be fed. What will each person receive? All right, well, what will they receive? Well, they'll each receive, all right, 3 hot dogs. Okay, because 3 times 15 is 45. And they'll each receive how many bags of chips? 2. 2 bags of chips. And I'll just write 2 chips because 2 times 15 is 30. And that's how that works. Okay, we have one more. Let's take a peek at it. The Valquez family visits their grandmother every 3 weeks and hosts a neighborhood party every 8. So 3 and 8. Every 16th week, the Valquez family takes a day to go hiking. All right, so let's take a look at this thing. All right. Oh boy, excuse me. All right, so let's get set up here. Every 3 weeks, they host every visits their grandmother and a neighborhood party every 8 weeks. Every 16th week, they take a day to go hiking. So the first thing that we're going to do is we're going to find it's after how many weeks will they both visit their grandma and host a party. So we need to deal with these two numbers. And we're going to deal with the multiples of these two numbers of 3 and 8. I'm just setting it up. So we're looking for the first common multiple when we count by those numbers that appears in both lists. Okay, and I'm just counting by the numbers. And if I keep going, I end up with that, 24. And a lot of times when you just multiply these two, you're going to get the LCM. But that always doesn't just happen. Sometimes you'll find out that it doesn't work that way. Okay. So every 24 weeks is the answer there. So now we want it after all three events. Okay. All three events. Okay. Well, so what I would do is come down here really and just continue. And I would make another bar. And if I counted by the numbers, okay, and I'm going to continue this out. 16, that was times 3, times 4 is 32, okay, and times 5 is 40. But you know what? Let's go ahead and use our calculator. When we get a triple stack, let's use the calculator. All right, that's fine. So how do you do that? So we go down to math. We're going to come down to LCM, and let's enter 3. We already know what the LCM of 3 and 8 is. We figured that out to be 24. So we need the LCM of these two numbers, essentially, 24 and 16. So let's just go ahead and punch that in. 24, hit second, comma, hit 16, and hit enter. And you're going to find out that it's 48 weeks. Now, what does that mean? That means that, all right, when will all three events occur on the same time? Every 48 weeks. So anyway, that's today's lesson. Let's flip the page. We're running over on our video here a little bit. Anyway, I'll tell you what. Number 6, you can use your calculator since it's a triple stack. Okay. And I want you to find the GCF and LCM of those numbers. Okay. I want you to do 7 and 8. All right. And then number 9, I'm not going to worry about because it has that Venn diagram. I don't want to confuse you. Okay. All right, guys. Have a good day. I'll see you.